Our group is investigating music, memory, and learning. For this project, we've looked at some psych studies that help us inform our conclusion. Our thesis is how does exposure to music mold specific brain structures and consequently their corresponding skills. We'll first discuss music and its effects on the brain's memory structures, then we'll dive into how music affects academic success.
First off, let's look at music's observed effect on memory. To do this, we would look at a study titled The Positive Effect of Music on Source Memory. The aim of this study is to investigate whether episodic memory can be improved by background context of instrumental music. Now, in order to understand music's impact on memory, episodic in this case, we need to clarify some terms on memory. Episodic memory. This is the memory for events occurring at a particular time and place. Therefore, episodic memory contains information about both the content of an experience and the context in which the experience has been encoded. Now that has been clarified, the aim to investigate whether episodic memory can be improved by background context of instrumental music now makes more sense. To achieve this aim, they looked at two things. The first one is whether verbal memory, which is the memory of words, can be improved by music in terms of both item and source memory. Now, what is item memory? Item memory is the memory of content. And what is source memory? Source memory is the memory of context. Let me give an example to differentiate between the two. Okay, we can recognize a person we've seen. In this case, he's considered a content without being able to retrieve where and when we met them, which is the context. Now, the second way to achieve their aim was to check whether the facilitation provided by an auditory context is a music specific or could be due to auditory stimulation in general, which just means they wanted to check whether making any form of sound could produce the same results and if music was special or not. Now, let's look at the method of the study. The participants involved 20 undergrad students, 13 women and 7 men, which all reported to have normal vision and hearing, non-musicians and native French speakers. There will be 3 encoding contexts, one with music, another with environmental sounds, and then one with just silence. The music used here was instrumental in order to avoid any interferences, and then the environmental sound used here is sound of waterfall. The experiment consisted of 90 French word lists, which were divided into 2 sets of 45. 45 words were given to half of the participants and the other to the other half, which meant 10 participants had 45 sets of words. Now, for each participant that had to go through 45 words, they were divided into 3 sets of 15. Each set of 15 words had a different context, so either silent, environmental sounds, or music. Now, let's move on to the procedure of the experiment. Firstly, the participants were tested individually and seated at a PC in a quiet room. Then the participants had to encode words with background context for 5 seconds. So this background context included music, environmental sounds, and silence. So 15 words per context. Then after all 45 words, there was an interference stage where they were asked to do a task for 5 minutes. And this interference stage is very important as it is able to test long-term episodic memory. Then they were tested on the original words. This was the retrieval phase, and this included 45 old words mixed with 45 new words, and for each subject had to indicate if they had seen the word in the encoding phase. And this was done using yes or no on the keyboard. And if they selected yes, they were asked to indicate the context. The participants were also tested for items and source memory via a method. Okay, moving on to results. As seen on the graph on the right, we can see that the black bar, which represents music, the gray, the environmental sounds, and silence, the white bar, has been plotted. The first graph is the item memory graph, and the second is the source memory. And now we see that in both, music has the highest and greatest impact, while environmental size and silence are relatively the same size. A post hoc LSD result shows that subjects better tend to retrieve words previously encoded with music than environment and silence, and also showed that subjects better retrieve the musical source. All in all, this study provides us with the evidence that music does indeed have an impact on our memories. However, this is not conclusive for all forms or types of memories, but this can only be concluded for the episodic memory in relation to verbal encoding, as studied in this experiment. And this journal also reveals that background music and not some random plain sound helps in encoding, which leaves us with the question: what specific parts of music help with encoding? Is it the rhythm, the genre, etc.? But a limitation to this study is that it lacks biological evidence, which will be covered in the next few slides.
Next, we're going to look at music's effect on memory from a biological perspective. The two studies we will be looking at are enhanced articulatory rehearsal mechanisms explain higher verbal memory, and musical training mediates the relation between working memory capacity and preference for musical complexity. The first study we look at relates articulatory rehearsal and higher verbal memory. In this study, it first looked at previously done research, which consisted of exploring that music listening correlated to improved memory. However, this study wanted to explore which brain structures were responsible for the improvement involved, and how could this be tested? The way they were going to test this was by looking at the model of working memory and determining whether the music impacted or strengthened the visuospatial sketchpad or the phonological loop. We learned in Psych 1101 that in the model of working memory, there is a main central executive which controls two subcomponents known as the visuospatial sketchpad and the phonological loop. The visuospatial sketchpad is useful for visual memories, and the phonological loop is more useful for auditory and heard memories, in addition to language learning and speech. The methodology used in this study was by giving a group of trained students or children who were trained in music and students who were not trained in music a set of words to remember and also a set of visuals and images to remember. And on the next few slides, we'll discuss how these results turned out. The demographic for this study included children aged 6 to 15 with and without musical training. In addition, there were a long list of control variables that were used to make sure that the participants in the study were consistent in their behavior. These include intelligence, musical aptitude, and personality. From this graph, we can see that the musician group, on average, was able to recall a higher number of words. The reason for this, which this study uncovered, was because the phonological group was strengthened after musical training. This is because the phonological group is associated with auditory sensing and memory, and when participants were put in music training, they trained that region of their brain, because as a musician, you have to listen to yourself, and also when you're part of a group, you need to synchronize your playing with the rest of the group, and that requires a lot of work by the phonological region of the brain, whereas the visuospatial region of the brain is not activated during activities like this. So what we noticed in this result, in this study, was that number of words, which is related to language and auditory learning, are all improved because they were exercised during music training. However, when the same group of people were given visual tasks and asked to remember visual cues, they both performed the same. Both the musician and the non-musician group performed the same because the visuospatial region of the brain is not improved by musical training. And that was one of the goals of this study, to determine which part of the brain is actually responsible for music lessons and improving verbal memory. As is the case with most studies, there are some limitations and also potential extensions for it. The first being, the visuospatial area showed no improvement between the groups. As mentioned on the previous slide, the visuospatial area is not strengthened by musical training, so it makes sense that it was not, there was no visual memory improvement between the two groups. Next, when the study was applied to adults of a larger age group who had further developed brain structures, a comparison couldn't be made between children and adults. Next, there was a limited sample size, and it was not evenly distributed between males and females. And finally, an extension question that the study had was, what are other kinds of memory that could benefit from the phonological area being strengthened due to music training? In order to answer the question posed on the previous slide, we looked into another study done a couple years later, which related musical training and the working memory capacity of participants. And what this study found was it was truly the phonological region that was improving people's verbal memory due to musical training, and also there were some other skills related to memory that were improved. And we can see that in the graph over here that have relatively close means with each other and very low, very high confidence intervals.
How does music affect performance? In this study, we'll be looking at how students who do study music compare to students who don't study music in a Portuguese middle school environment. Due to confounding variables, researchers have trouble researching music and its impact on intelligence specifically compared to researching just one variable at a time. The problem is that when you have different factors such as socioeconomic status, intelligence, possible life situation, aspirations, illnesses in the person's life, or the student's confidence, it's difficult to look at the effect of one single variable on intelligence. So how do we study this? Previous researchers have already found that socioeconomic status has a strong influence on academic achievement. This means that even though socioeconomic status has a strong influence on the academic achievement, if it also has an influence on the person's likelihood of performing in some kind of artistic program such as music, then it'd be difficult to look at just that artistic program to see if it has any effect on academic achievement. So this is the solution that they came up with. They decided that instead of looking at just one variable, they were going to look at how music affects intelligence on many different ways, while controlling for socioeconomic status, motivation, intelligence that was already predefined, and specifically GPA. So they're going to look at GPA as the Y variable or as the independent variable, while using socioeconomic status, motivation, and intelligence as ways to distinguish and normalize the data. The students that ended up being used in the study all came from similar urban schools in Portugal. Out of 110 students, 62 of them had 6 or more years of musical training, which means some kind of class or coursework involving music, and 48 of them had no musical training whatsoever. On average, each student that did music had about 7 hours of musical instruction per week, and all of them followed the same basic music curriculum of Portugal. The procedure used was one where a student was defined, and a student was actually, every student is graded based off of their socioeconomic status, motivation, intelligence, and after this, they would be tested once in 7th grade and once in 9th grade. The graph to the right shows the results of testing. As you can see, the music students perform better generally than the non-music students. And there's more variation for the non-music students, whereas the musical students ended up being more closely related and more closely associated together with a higher GPA. and higher performance in terms of academic achievement. This chart shows the average grade for each group that was tested by the study. As you can see, natural science is the group that was is the subject that was most benefited when a student was deciding to study music versus a student not deciding to study music. Also, you can see the standard deviations for each group. So what does this all mean? Well, according to the data, it seems like there has to be some kind of positive association between music and academic achievement. Also, the data shows that demographic, motivational, and cognitive factors are important when looking at the future potential academic achievement of a student. As with any study, this one also had some limitations and pitfalls. The first thing to note is that they didn't account for any varying personality among the Portuguese children, which is a big deal considering that personality probably has much more of an impact than music comprehension on a student's potential academic achievement. Another problem is that in terms of finding and normalizing the data for the socioeconomic status of the students, they only looked towards the level of education for the parent. So if a parent didn't go to college, yet still made a lot of money and could provide for their child and could provide a good life for their child, they would still be considered a lower socioeconomic status than a parent that did go to college and doesn't do that for their child. Finally, they also didn't look at how music could affect students prior to the 7th and 9th grades. They only looked at those 2 years when music learning could affect them much more so a younger child. Previously, we only really looked at how music and learning music can affect one's memory and how it can affect how the person learns and their grades and academic achievement. But we didn't study how music in real time could affect someone's ability to remember something or affect their ability to learn a new skill.
Many of us would love to listen to music during lectures or exams, but how much of an impact does music have on individual academic performance? A research study done by students enrolled in Caen Normandy University investigates if listening to music during a lecture will influence the affective states of college students and their academic performance. The group of researchers hypothesized that music would mainly affect exam performance due to the elicitation of positive effect and reduction of negative effect. In this study, researchers took a sample of 249 undergraduate sports sciences students who were all enrolled in an introductory sports psychology course. The students were split into 2 groups with equal academic performance. The control group had 120 students, 25 females and 95 males. The experimental group had 129 students, with 34 females and 95 males. Because both groups aren't exactly the same, the researchers took a mean examination score and found no difference between the two. After gathering their participants, the researchers simultaneously played a sports psychology lecture and music at a low volume to the group of students for them to listen to. The lecture was 1 hour long, and the undergraduates were not allowed to take notes. The researchers had created a 25 multiple-choice questionnaire for them to answer after finishing the lecture. The music for this study was chosen to elicit a positive effect. The researchers decided on classical music without lyrics so that there was no confusion for the students to understand the lecture. Going into the study, the students did not know the content of the lecture and that music would even be played. The students were only told to concentrate on the lecture and that they would have to take an exam after. 6 pieces of music were selected from a set of music that had already been used to elicit positive effect. The songs played include A Little Night Music, Allegro, Mozart, Concerto for 4 Violins in D major, Vivaldi, The Blue Danube, André Rieu, The Nutcracker, Tchaikovsky, Brandenburg Concertos No. 3, Allegro Moderato, Bach, and Ninth Symphony Ode to Joy by Beethoven. To measure effect, the researchers chose an approach used by Watson, Clark, and Tellegen in 1988 that categorizes discrete emotions into higher-order dimensions on the basis of their overlapping properties. These authors developed the positive and negative effect schedule, which I'll refer to as PANAS. It is a questionnaire containing 10 items to assess positive effect and 10 items to assess negative effect. The students had to rate to what degree they currently felt each emotion on a Likert scale of 1, very little, to 5, very much, similar to what is shown on the slide. This table shows descriptive, statistics, and results from the study. Results are now presented according to effect, induction, MCQ score, which is the multiple choice questionnaire, and predictive power of effect for academic outcome. The baseline effect of the two groups did not differ, neither for positive effect nor for negative effect. The 2 times 2 repeated measures revealed a main effect of assessment time on positive effect and negative effect. They both decreased between T1 and T2, which you can see on the screen. The experimental group's MCQ score was 14.5, which is greater than the control group score of 12.2. This finding is significant. Moving on to Table 3, to determine if these numbers were accurate or reliable, the researchers used a hierarchical regression analysis, or HRA, with the multiple choice questionnaire as the dependent variable. The first hierarchical regression showed that positive effect and negative effect at T2 explain significantly 6% of the MCQ score variance, as seen in Table 3. More precisely, positive effect at T2 was found to predict a positive MCQ score, while negative effect at T2 was found to predict a negative MCQ score. These are the beta values that are 0.22 and negative 0.18. Moreover, music was found to explain 4% of additional variance for the MCQ score. This is that beta equals 0.2 value. The overall model accounts for 10% of the MCQ score variance. The second hierarchical regression showed that the change in effect does not predict the MCQ score variance. However, the music significantly explains 5% of the multiple choice questionnaire score, and the overall model accounts for 5% of MCQ score variance. At the end of the study, the researchers found that a decrease in positive effect was much more significant in the control group than in the experimental group, yet no such effect was found for negative effect. This allowed us to conclude that music played a role in maintaining positive effect during the lecture. As stated earlier, the MCQ score for the experimental group was significantly higher than that for the control group. This means that music could have played a role in academic outcome. In the past, music was found to influence cognitive tasks and learning directly, but these studies were focused on very specific abilities. In contrast, this research study involved a large range of cognitive abilities. It is possible that music provoking a change in the learning environment influenced the students' motivation to remain focused during the lecture, which led to better performance on the MCQ. Yet, the researchers did not examine the students' motivation, and that is a limitation in the study. This finding could also be explained by the potential activating effect of music, which could have in turn improved cognitive functioning. In addition, it should be noticed that the MCQ score might have been influenced by prior knowledge, even if the students had not studied the topic of the lecture before at university. The first hierarchical regression analysis revealed that effect at T2, which is just before taking the exam, predicted the MCQ score significantly. It was positive for positive effect and negative for negative effect, as this is shown on the table. The influence of effect could be related to achievement goals and might be used to sustain motivation. The second hierarchical regression analysis showed that a change in effect at T1 and T2 for both positive effect and negative effect did not predict the MCQ score. This means that if effect did influence academic performance, it was not due to the change in effect induced by music during the lecture. Interestingly, in both regression models, music was found to account significantly for an additional part of the MCQ score variance. This means that effects elicited by music are not the only responsible mechanisms for the increase of academic performance, and further research should be conducted. In conclusion, this study provided valuable insight into the influence of the learning environment on academic outcome, and specifically the influence of classical music on MCQ performance following a lecture. Even if the underlying mechanisms of the influence of music on learning during a lecture remain unclear, the necessity for more research about the role of effect and motivation in the academic environment is apparent.
So why does music actually have this effect? What's going on in the brain when this occurs? And does everybody do better when learning with music? Or is it just some part of the population? Are some people better? Or are some people simply learning more? White matter structural connectivity predicts short-term melody memorization and rhythm learning in non-musicians. According to these researchers, they scanned the brains of 44 non-musicians who had some experience with music class but no skills touching an instrument, and they tested how well those same 44 non-musicians could complete examinations in terms of memory, for rhythm, and for melody. Some important terms to know are the arcuate fasciculus and the fractional anisotropy. Scanning the brains of these subjects allowed scientists to see exactly what each part of the brain had in terms of its volume. And they could specifically see where how much white matter was in each part, and they could compare those to the results of the musical skill tests. So what does what here? Well, here's what the study found. The macro and microstructural organizations of the AF, in terms of volume and FA, predicted the learning rate and learning speed of musical tasks, but only in the right hemisphere. Specifically, the volume of the right anterior segment predicted synchronization improvement during the rhythm task. And the right long segment was correlated with the learning rate in the melody task. The volume of the FA of the right whole AF predicted the learning speed during the melody task. So what did we just read? Well, I think it's pretty interesting. It just might take a second to look through and really understand what they were saying. But basically, music ability is entirely quantifiable and identifiable in the brain. Also, different musical abilities are isolated to positive correlations of the volume and white matter in different sections of the brains. Specifically, rhythmic ability and melodic ability are in very different areas of the brains, and those are positively correlated with white matter in those areas. In conclusion, it's mostly self-evident that people understand that music and intelligence are related. Many parents sign their children up for programs just in the hopes that it'll eventually help them with their academics. Exposure to music can shape an individual's brain, demonstrated by increased white matter being present with those more inclined to music, by showing correlations with academics, and by showing how both episodic and working memory are benefited through musical training.